Good morning, dear student. Hope you all are doing well. So from today we will start a new chapter, which is solution. Okay, unit 2, and from this chapter, total 5 marks will come in your exam. The main objective of this chapter is to understand about solution. Okay, so first we'll discuss about the definition of solution. Then we'll go to the types of solution because there are many types of solutions are there, and when we are talking about solution, then we have to express them. Okay, so about their concentrations. Okay, so to express the concentration, we need some terms like normality, molarity, molality. Okay, weight by weight or weight by weight percentage or weight by volume percent, volume by volume percent. Okay, there are many way of expressing those concentrations, so we need to know about them. Okay, actually we often use in practical also. So sometime I think you have already gone through this type of questions, ppr 1 molar sodium chloride solutions or ppr 2 molar concentrate 2 molar sulfuric acid solutions. Okay, so we have gone through this type of questions. So what about this actually, normality, molarity? So we will discuss in details about them in this in this chapter. Okay, then we'll go to the solubility of gases, different types of gases in some specific liquids. Okay, and one law will come here. Okay, so this is very important one, and the solid solution, and then we'll go to the colligative properties, and these colligative properties are very important, like relative lowering of vapor pressures, elevations of boiling points. Actually we use actually we often observe actually this this colligative properties like lowering of vapor pressures. Okay, so we use the pressure cooker to cook some things. So actually these colligative properties are there. Okay, and also the elevation of boiling points. We add some salt to cook something. So why we actually add salt to cook some things? Obviously this will increase the taste. Okay, and also additionally some other chemistry involves actually during this process. Okay, during this cooking process also, when we add some salt, some chemistry will be there. Okay, occurring. So this is very interesting. Okay, and the depression of freezing point and osmotic pressures. Okay, so what is osmotic pressure? Actually we use this reverse osmotic pressure technique in our modern filtration process. Okay, the instrument which is used to actually filter the water, we use this technique. Okay, reverse osmotic technique. And then we can even calculate the molecular masses of some unknown compound by using the colligative properties. Okay, and also additionally we have to also discuss about the ideal and non-ideal solutions, and most importantly we have to actually discuss about some numerical problems related to this solution chapters. Okay, so because in board exams as well as the entrance exams, okay, so many questions come from this actually the numerical parts. So we need to know about the numerical techniques. Okay, how to solve some questions. So we have to clear the concept of the solution chapters to solve the numerical problems easily. Okay, now let us discuss about the solutions. Okay, the types of solution and the definition of solution. So actually all the things, okay, all the concept will be actually discussed from your NCERT books. Okay, in this video or in this the series of these classes, we're going to only discuss about the NCERT book. This chapter is start with a very interesting sentence, which is almost all processes in body occur in some kind of liquid solutions. Okay, so that means that all the processes are occur in our human body. Okay, or some animals or any living bodies. Okay, some solutions are there, some liquid solutions are there. Okay, and even if you look at our normal life, then hardly we encounter some pure substances. Okay, we almost always encounter some types of mixtures. Okay, like actually solution is a type of mixture. Okay, and like as for example brass is a mixture of copper and zinc, and some other examples like German silver, which is a mixture of copper, zinc and nickel. Okay, and bronze is also a mixture of copper and tin. So these all the things. Okay, these all the there are actually many other examples which have these types of some types of mixtures of some pure substance. So basically we use some mixtures of some different types of pure substance to enhance their properties. Okay, sometimes we use some mixtures of some metals to actually resist the corrosive natures or corrosive behavior of the substance. Okay, and one very interesting example is given here, which is actually the example of fluoride ions present in the water. Okay, so here it is written here 1 parts per million. Okay, so ppm. So it is actually also a representation of the concentration of some solution. Okay, ppm is, we're going to discuss about this, what is ppm, okay, in details. So actually this is a scale. Okay, so a scale of actually calculating the concentration, or we can calculate the concentration by using this scale if the concentration of the solution is very low. So it is given that if the concentration of the fluoride ions in water is almost 1 ppm, then it will going to actually affect positively. That means it will going to prevent the tooth decay. Okay, but if the concentration will almost 1.5 ppm, then it will going to affect negatively. Then that means it will going to actually damage our teeth. Okay, and even if the concentration of the fluoride is very high, okay, then even it will going to act as a poison. Okay, nowadays the scientists are trying to remove fluoride from drinking water. In Assam, mainly many hilly areas, like mainly in Karbi Anglong district, okay, a huge amount of fluoride ions are found in drinking water. And in Tezpur University, actually, our respected sir, scientist Dr. Ramin Kumar Dotto sir, he able to create a procedure to remove the extra fluoride ions from drinking water. Okay, in some area of Assam, arsenics are found also in the drinking water, and this is a very dangerous for health. Okay, so in the presence of actually the arsenic actually can cause cancer. Okay, so we have to actually remove the arsenic from the water. An interesting example is the intravenous injections. Okay, so what is intravenous injections? Actually the injections which are injected in our vein. Okay, that means our blood. Okay, so the concentration of the intravenous injection should be exactly same with the concentration of the blood plasma, otherwise it will going to exhibit some side effects. Okay, so we have to be careful with this. Okay, so this is all about the some examples of some solutions which are encountered in our daily lives. Okay, so in this chapter actually we will going to mainly discuss about the liquid solutions. Okay, that means the solutions which is in the form of liquid, that means in the form of liquid state. Okay, now coming to the definition of solutions. Okay, so actually solutions are defined as the solutions are homogeneous mixtures of two or more than two components. Okay, so this is the definitions. So what is the meaning of it? The meaning of it is that we have to mix some components homogeneously to prepare a solution. Okay, so when we are talking about homogeneous mixture, so we have to taking care of two important points. That means a homogeneous mixture of solution can be only defined by two important factors. Okay, and these two important factors are, the first one is the compositions and the second one is properties. So actually in case of a homogeneous mixtures, the compositions of the homogeneous mixture should be uniform throughout the mixtures. That means if the compositions of the the solution in this part is, let's suppose, C1, then the composition of the that mixture or that solution at this part should be also same. That means it should be also C1. Understand? Then only we can say that that is, or that mixture is actually a homogeneous mixture, and this is the homogeneous solution. Okay, so what is the meaning of compositions? Actually the composition means actually the amount of components, actually how much amount of components is present in that particular portions. Okay, so in case of homogeneous mixture, the the components or the ratio of the different components should be similar throughout that whole mixture. Okay, so then only we can say that that mixture is a homogeneous mixture, or in other words we can say that to become a homogeneous mixture the composition should be similar throughout the system. Understand? And the next point is what? The second point is the properties. So there are mainly two types of properties. We already know that. The first properties is actually physical properties, which includes the appearance, okay, melting point, boiling points, okay, like that. And the second is chemical properties. Okay, so in case of a solution, actually we are talking about the physical chemistry now, so we are just concentrate on our physical properties. Okay, so here the properties should be same throughout the mixture. That means the boiling point or the visibility, okay, or the appearance should be similar throughout the mixture. Then only we can say that that solution is your homogeneous mixture. Understand? So in conclusion, what we can say? We can say that in case of a homogeneous mixture of two or more than two components, the compositions and its properties should be uniform throughout the mixture. Okay, then those homogeneous mixtures are known as solutions. So sometime in exam they may ask you the definition of solutions. Okay, now let us discuss about the definitions of solvent and solute. Okay, from the above discussions we are able to know that solutions, or you can say the homogeneous mixtures, okay, are actually mixtures of what? Two or more than two components. Okay, and the components which is in the large quantity is known as solvent. Understand? That means there may be many components. Okay, and the components which amount is largest, okay, or which amount is higher than the other components is known as solvent. Simple. Okay, and the other components which are present in that solutions are known as solutes. That means in other words we can say that the solvent is known as the component of that mixture or that solution which is in the largest quantity, and the other components of that solutions are known as solutes. And in your syllabus only binary solutions are given. Okay, that means only two components will be present in that solutions. Okay, so that means one component will be solvent and other component will be your solutes. Understand? The component which is in the higher amount which is actually your solvent, and the component which is in actually lower amount is known as solute. Okay, in case of binary solution, because only two components are there, no? One is solution and one is solvent and other is solutes. Now let us discuss about the classifications of binary solutions. Okay, so we already know that in case of binary solutions only one solvent and one solute will be there. Okay, so again we know that the solution is mainly defined by the nature of the solvent. That means if the solvent is in gaseous form, then that solution will be your gaseous solutions. If the solvent is in liquid form, then the solution will be your liquid solution. And if the solvent is in solid form or solid state, then the solution will be your solid solution. Okay, so that means depending upon the nature of solvent, the solutions are divided into three categories: gaseous solutions, liquid solutions, and solid solutions. But again, depending upon the the nature of the solute, okay, the solutions, that means the gaseous solutions are further classified into three categories, liquid solutions are again classified into three categories, and also the solid solutions are also classified into three categories. Okay, depending upon the state of the solutes. Now let us discuss one by one. Okay, so the first category on the basis of the nature of solvent is what? Gaseous solutions. Okay, so this is again classified into three categories. Okay, that means three subcategories. The first subcategories of gaseous solution is gas in gas. Okay, that means the solute is gas and the solvent is gas. Okay, so we usually say it like gas in gas. Okay, So the example of gas in gas is mixture of oxygen in nitrogen gases. And the second subcategory of the gaseous solution is liquid in gas. An example of it is chloroform mixed with nitrogen gas. And the third subcategory of gaseous solution is solid in gas. Example, camphor in nitrogen gas. Second, classifications on the basis of the nature of solvent is liquid solutions, and the sub classifications of the liquid solution on the basis of the solute, that means the nature of solute, is first one is what? Gas in liquid. Okay. Example, oxygen dissolved in water. Okay. And the second subcategory is liquid in liquid. Example, ethanol dissolved in water. So actually this ethanol dissolved in water is mainly used in your the sanitizer. Okay, so mainly more than 60 or more than 70% ethanol are actually mixed with water to prepare the sanitizer. Okay, so also some other components are also used, like hydrogen peroxide, a little amount of hydrogen peroxide, and also some aloe vera. Okay. And the third category is your solid in liquid. So there are many examples of solid in liquids in case of liquid solutions are observed, like sugar in liquid, that means sugar dissolved in water. Okay, or some salt in water. So there are many examples. Okay, and these liquid solutions are very important because in this chapter we'll only going to focus on these liquid solutions. Okay. And the third category on the basis of the nature of solvent is solid solutions. Okay, and further we classified this solid solution into three subcategories on the basis of the nature of solute. And the first subcategory of this solid solution is gas in solid. Example, solution of hydrogen in palladium. And the second subcategory of this solid solution is liquid in solid. Example, amalgam of mercury in sodium. And the third subcategory is solid in solid. So this is also a very important actually subcategory of solid solution, which is solid in solid. Okay, actually most of the alloy, okay, like copper dissolved in gold and other types of alloys are actually examples of this category or this subcategory, solid in solid. Okay. So hope you understand all about the introduction part of this solution chapter, and the definition of solution, and also the the category or the classification of the solution. And in the next class we will discuss about the the different way of expressing the concentration, or the way by which we can express the concentration. Okay, there are many ways are there to express the concentration of a solution, like molarity, normality, parts per million. Okay, weight by volume percentage, volume by volume percentage, gram per mole, gram per liter. Okay, so there are many different types of ways are present by using which we can actually express the concentration of a solution. Okay. Also, additionally, there are some numerical problems are also there. So we'll try to do some numerical problem related to this topic, okay, in the next class.